Hi everyone, joining us today is Dr. Pramod Khargonekar, Vice-Chancellor of Research and Professor at the University of Irvine's Department of Electrical Engineering and Computer Science. Dr. Khargonekar, would you like to tell us a bit more about your background in research?
All right, so I will talk a little bit about the subject of my presentation, and then we can have a Q&A after that. And the way I've thought about this is, I know you're all high school students. I have two children of my own, both have gone through high school long time ago. So I kind of have a little bit of an idea of what high school students think about. So this is not quite the best title, but I think it gives you an idea of what I want to talk about. So my background, I was born and raised in a small town, medium-sized town in India called Indore, which is on this map. And the first 10 years of my life, I was in this small village called Kannur, which you can see on the screen. This village, this is 1956, probably had less than 2,000 people. Okay, there was no electricity, there was no running water, and so my first 10 years of my life were in that small village. This is the temple in Indore, which was close to our house when we moved to Indore, which is a little bigger city. Both my parents were high school teachers. My father taught essentially political science, and my mother taught Sanskrit, which is a very ancient language of India. And then I came back. So after my 10 years in this small village, we moved back to this city called Indore. We kind of lived close to this temple. And then I went to this high school in Indore and finished my high school. And then for my undergraduate, I went to IIT Bombay, which is one of the premier institutions of higher learning, certainly in engineering. Even then it was one of the best, and now it is like absolutely one of the best in the world. People joke that it's harder to get into IIT Bombay than it is to get into Harvard or one of the really elite universities in the US. So this is my undergraduate. From there, I came to do my PhD at the University of Florida. So this is the building at the University of Florida where I was a graduate student. I did a master's in mathematics and PhD in EE in 1980 and 81. So that was my education. And then I've been a lifelong professor. So I started my professorial journey at the University of Florida and then moved to University of Minnesota, where I was on faculty of electrical and computer engineering. That's the building where my office was towards the end of my stay in Minnesota. And then I moved to University of Michigan, which is their EECS department was in this building. So I was there from 1989 to 2001. I became department head of EECS at Michigan. And then I went back to Florida as Dean of Engineering. Okay, so I went back to Florida as Dean of Engineering, and I've been now at UC Irvine. So you see a picture of the engineering building at University of California, Irvine. So I was, like I said, I've been a professor all my life, and then I've also been a leader. So I was department head at University of Michigan. Then I was Dean of Engineering at the University of Florida. I'm now Vice-Chancellor for Research at UC Irvine. I was the head of the engineering directorate at the National Science Foundation, which is the premier science funding agency in the United States. I was in charge of roughly $1 billion in research funding that we gave out to universities all over the United States. So I was there, and I was also, for a very brief period, Deputy Director of Technology at ARPA-E. So that's been sort of my professional journey as a leader. And my research interests over this 40 plus year career have evolved over time. So initially I was doing very, very abstract, highly mathematical work in control systems theory. And then I got interested, especially after I moved to Michigan, interested in applying a lot of that theory to manufacturing. So did quite a bit of work in the 90s on applying control to manufacturing of chips, computer chips that are in our computers and cell phones. companies like Intel are major manufacturers. So their processes are extremely sophisticated. And how do you control them for accuracy and productivity and uptime and things like that? So we did a lot of work on that. Did a lot of work on manufacturing of essentially you can think of as automotive manufacturing. How do you make those manufacturing systems more reconfigurable as your demand changes, your models that you're producing change? So did a lot of work on reconfigurable manufacturing. And then starting about 2010, I got involved in renewable electricity. So wind and solar, they are not, our electric grid is not designed to handle these wind and solar power. Okay, so you have to do a lot of pretty sophisticated control to integrate these wind and solar power into our electric grid. So for the last 10 years, that's what I've been doing. And in the last 3 years, I sort of started to branch off into learning about machine learning, deep learning, and applying that for control problems. So that's sort of been evolution of my research interest. And we can talk about this in the Q&A period if you like. I want to spend the rest of my talk as to what I would tell high school students like you. So this is a chart that captures essentially the history of humanity since the start of industrial revolution. So these are what are called innovation cycles. So, and they go in these waves. So the first wave was water power, textiles. This was all in the UK, Britain and Europe, and iron. And then the second wave was steam power, rail and steel. The third wave was electricity, chemicals, and internal combustion engines. So think of the whole automotive revolution that happened in late 1800s and early 1900s. And then you get into the fourth wave, which is sort of getting into more like the 40s, 50s, 60s, petrochemicals, electronics, and aviation, so airplanes, okay? So you see that big wave of innovation. I personally, sort of my life, I think has gone in this fifth wave, which is digital networks, software, new media. So think, everything starting with the personal computer and onwards. Personal computer, internet, cell phones. And now the sixth wave is upon us, which is, robotics, AI and IoT and clean tech, renewable and electric vehicles and this whole thing about decarbonizing our economy. So I think you guys who are in high school now, I think are going to enter in this, somewhere here. Okay? And I'm going to say something about what I think your future holds. But an example of the impact of all these waves is, if you look at GDP per capita from 1820 to 2018, you see this dramatic increase from essentially where all the countries are more or less in the same bucket, I mean, there wasn't that much difference between, say, Western Europe and South Asia, which is India, right? I mean, I'm from India, and then Africa. I mean, there were some differences, but not a whole lot. And now you see this dramatic rise of United States, Canada, Japan, Australia. Then you got Western Europe, which is, a little bit behind, but pretty close. And then you have Eastern Europe, Middle East, East Asia, we go somewhere here. South Asia is here, but growing very, very fast. India is really going very fast. And then you have Sub-Saharan Africa. So I think you will determine where these curves go, okay? So think about 2018 or 2022 to 2072. That's the story you are going to write, okay? So just a few more comments and then we can do Q&A. So first comment I want to make to you guys is what is called Amara's law. And what it says is that we tend to overestimate the effects of a technology in the short run. And by that he meant like next couple of years. So we think, oh, huge things are going to happen, and it's usually an overestimate. We sort of blow up the impact of technology. But we underestimate the effect in the long run, by which he meant roughly 10 years or more. So the world, so one corollary of Amara's law is The world in 2024 will be, of course, different than 2022, but not as big a difference as what we will observe in 2032. So if you look back in 2032, the world will look quite different than it looks today. Okay, so that's sort of the Amara's law's gist, is you take a little bit longer period. It's hard to know where the world will be in 2032. We can have a rough idea of what it will be, but second set of thoughts for you guys in high school is you are in for a long game. Okay, you're in for a long game. A typical college graduate, so you're not even there yet. One of you is a sophomore, the other one is a senior. You're not even in college yet. But pretty soon you'll be in college, and at 22 you will be graduating. I guarantee you will work for 50 years or more. Okay, 50 years or more. Just think about that, and couple that to Amara's law that I just finished telling you about. The world will look dramatically different in 2075 or 2076 or 2080 by the time you finish your working life. And even then, you may not have finished your working life. I mean, you may still continue to work beyond 2080, but that's the game you're playing. You will have 5 or more careers. Okay, 5 or more careers you will have. You cannot imagine today what you will be working on in 2030, 2040, 2050, 2060, 2070, 2080. Okay, you are in for a very long game. You are not in a 100-meter race. It's not like you're trying to finish, very, very fast. Who can run 100 meters? Okay, that's not. You're in for a marathon, 26 miles. Okay, you're running a marathon. Your marathon is a 50-year marathon. You are not running the next 2 years or 3 years. You're running the next 50 years or more. So persistence, grit, resilience, dealing with ups and downs and changes are just as important as talent and opportunities. We all think that the brightest kids will make it to the farthest, and some of them for sure will. Okay, but those who have persistence, those who have grit, those who can handle ups and downs, those who can deal with changes are going to be just as successful as people with talent. So what's the end result of all this? Prepare for a long life of learning, growing, and discovery. Okay, learning, growing, and discovery. So that's what you need to be thinking about. College education. You are a senior. You're a sophomore. In 2-3 years, you will be thinking college education. Okay, when am I going to go to college? And if I can just guess based on your backgrounds, you are getting all kinds of signals. Oh, you got to go to Stanford. Oh, you got to go to Cal, Berkeley. You got to go to UCLA, or you got to go to Harvard or MIT. In my personal opinion, and I've been a professor for 40 years now. Pursuit of admission to highly selective, prestigious universities has become really unhealthy. The level of obsession with this, that if you don't get into Stanford, your life is finished, I think has reached very unhealthy levels. So I just want to caution you against that sort of thinking. It is possible to get very high quality undergrad education at many, many universities in the US, at least 100. In California, we are lucky to have the University of California system, 10 top universities. You will get a good education at any one of them. And you can go beyond that, okay? College education is a very important time of your life to develop strong foundations for lifelong learning. So in my previous slide, I said, prepare yourself for learning, growing, and discovery. The most important skill you can take away is how to learn. It's not actually learning a specific subject, okay? Of course, you should learn specific subjects that you're interested in. But what is far more important is developing an ability to learn and have that curiosity to learn new things. This is the final slide. It's a concept that I just absolutely love and adore. It's a Japanese concept called ikigai, okay? And it's a way to think about our life. And I'm going to talk a little bit. So I think most of you as students are thinking mostly about what you're good at. Oh, I'm good at math, or I'm good at English writing, or I'm good at physics, or I'm good at biology, or I'm good at software. Important, no doubt. Then you will ask yourself, what do you love to do? Now, if you combine what you love to do with what you're good at, you get what is called passion, okay? This is your passion. You can pursue your passion, and maybe you pick a profession that gives you a combination of what you love and what you're good at, and you pick a profession based on that, you will be in this intersection. Okay? Satisfaction, but feeling of uselessness. Over time, that's what will happen. You can then pick another combination, what you're good at and your profession and what the world needs. Okay? Again, it's a good combination. You could get to this intersection, which is comfortable because you're getting paid, you're good at it, and what the world needs, but a feeling of emptiness because you don't love what you're doing. So you're doing what the world needs, you're good at it, and you're getting paid to do it, but you don't love it. So you get into this zone where you're comfortable, but you're feeling empty. Then another combination is what the world needs, what you can get paid for, and what you love. Another great combination. You love it, the world needs it, and you can get paid to do it. What's the intersection you can get into? It's this one. Okay? And what is that? There is excitement, complacency, but a sense of uncertainty because you're not good at it. Okay? You've chosen something that you're not very good at. Then the fourth combination is what you love, what you're good at, and what the world needs. So it's delightful, you feel fulfilled, but you're not making enough to have a good life. So what the Ikigai concept says is try to combine all four. Try to look for something that you love, something that the world needs, so you feel like you're doing something worthwhile. You're good at it, so you do high quality work, and you also get paid for it. So if you combine, so don't go to extreme in any one of these four, or any even 3 out of 4 or 2 out of 4. 2 out of 4 is even worse. 3 out of 4 is also not as good, but 4 out of 4, a guarantee of a life of meaning. Okay, and that's what I want you to aspire for. That's it. I'm going to stop sharing unless you want to keep the slides on. Otherwise, we can do Q&A.
Yeah, and I guess we can start with first question. What sparked your interest in engineering and innovation?
It's a great question. If I look back on my journey, it was a pretty narrow and straight path, right? I was in India. We were very poor. My parents were, we were really lower middle class. We had no money. Like I told you, I grew up in a house with no water and no electricity. So survival was a big thing for us. And I was good at math. I was good at physics. So I thought of actually doing physics as my professional subject. But I realized that in India, at least at the time, to get a job in physics was practically not easy. So engineering was the next closest thing that one could do, where you could keep your interest in physics and mathematics, and yet you would have a reasonable professional life. So I think that's how I picked engineering.
Great, yeah. Karthik?
Oh, okay. Yeah, I guess in that case, we can just move to the third question we had, which was how can high schoolers dive deeper into engineering?
Yeah, that's a great question. There are many ways you can do it. First thing is try and see if you can get into kind of an introductory engineering course at a nearby university or nearby. So I think that would be one approach. Is almost every university now has intro to engineering type of courses. They also have freshman level design projects. So that would be another thing you could try and do, is to see if you can get exposed to a freshman design type project, because you guys as high schoolers are ready for it. You can approach local companies that are nearby. Many of you have parents who are in engineering, so see if there are a lot of these companies now offer something for high schoolers. Many universities have summer programs for high schoolers. So look for summer program where you can spend like 6 weeks at a university to get a taste for engineering. Lot of universities are offering those types of programs for high schoolers.
Okay, got it. Yeah, that was really interesting. Now, I just wanted to end off with saying, everyone, thank you so much for watching our interview with Dr. Khargonekar. Take care, and we'll see you all next time.